Welcome back. In this section, we will talk about box plots and violin plots. So what is a box plot? It is a method to graphically demonstrate the spread of data, also the locality of data, and if data is skewed in certain manner. Okay, and the important data point that is used is the quartiles. So this is how it would look like for a series of data. If I had a data point. So my data point is like this. If this is the array from 1, 1, 4, 5, 5, 7, 8, 10, and I plot a box plot, then this is what I see. So what is this point? It is the minimum of the series. This particular point is the maximum of the series. So minimum is 1, maximum is 10. This one is that this is just a one series. This particular point is the median of this particular series. This box starts at the first quartile and this ends at the third quartile. So the median is also the 50th percentile. So in our let's import our libraries, matplotlib.pyplot and the numpy library. And in this numpy library, you will get a np.percentile. Okay, and you can say that you want the 50th percentile. 50th percentile is your median. Okay, median is the 50th percentile, and it is also called as Q2, which is this part. Okay, so my median here is 5, which is this 5, which is denoting this is the median. If you want to check the first quartile, which is called as Q1, or it is the first quartile, and similarly this is 4.5. okay, this is the 4.5 where the box starts, and your Q3, which is the 75th percentile, that is called the Q3. It is the third quartile, which is 7.5. So by looking at this data, how you can check how the data is spread. So your data here, there is, it looks like, equal spread between the the data here. So this is the median. So from median to this minimum, and from median to, so that it looks like equal data points from the median to minimum and median to the top point. So let's see, 1455, yeah, approximately the same number of data points. Let us skew this data and plot the box plot. So let's suppose I have a lot of data towards the minimums, towards the left hand side, and the way to plot the box plot is plt.boxplot, and you give your series. By default, this is a horizontal, this is a vertical box plot. Let's mention it to be horizontal. So you can say vertical is false and you'll get a horizontal box plot. Now see that how the data, it's quite packed. This side is quite packed. So this is my midpoint. Between the midpoint and my minimum, there is very less distance. means the data is quite packed this side, and between the median and my maximum, it's a large distance. So it means that data here is widely spread out from the median point. That is how you're going to read the box plot. And it helps in a lot of variety of ways, which we'll discuss later on. Let us see a few more examples of this box plot. So suppose you get this kind of data from your database. You have imported it in pandas, and you have two columns which are of series kind. You can use box plot in that scenario as well. Suppose you are plotting the age of players, or you're plotting the salary, then you would know the salary groups, how they are skewed. Okay, so for example, you have these two series and you want to show them in a single plot. So you can do a plt dot box plot, and they are overlapping each other, and this is not so this is not what we want. We want the series from, so this series and the second box plot here. So let's see that how to do it. So like in the histogram we mentioned, the series in a list, comma separated, the same way we'll mention it here, comma separated list. And you would see that your box plots are printed like this, and you would also notice a particular dot here. Okay, not a dot, a circle here. This is called outlier. Okay, so I'll talk what the outlier is. Let's look at the box plots first. So this series, which was a second series, the first one that we draw, this is the median. From the median to the max looks like spread out, and this from here looks like packed. And this series, so there is a data which is starting from 1 going up to 17, and then suddenly there is a data point which is 40. Okay, so from 1 to 17 is shown here. This is the median of the series, and this is the outlier. When you look like the outlier, outlier is something which is lying outside the normal range. Okay, so when you see spikes, so suddenly let's say temperature has gone too much up and or too much down, a spike in any direction, upside or a downside, those spikes are generally called outliers. So in your normal scheme of things, when you have a data in the normal scheme of things, then everything is going perfectly fine. But if there is some data point which is not in the normal scheme of things, you can also use this particular plot for anomaly detection. Okay, so this is an anomaly. Why suddenly the data point 40 has come, wherein the normal things lie between 1 to 17. So this is calculated by your box plot, and it is plotted as a circle. It could come either ways. If I have a data point which is minus 20, okay, I have outliers in this series in both the direction, the downward direction as well as the upward direction. So what is an outlier? How do you calculate an outlier? So if you look at this documentation of the box plot, the way it calculates the outlier is your, on the upside it is quartile 3 multiplied by 1.5 times of the difference between interquartile range. So on the upside it is Q3. So there is something called as an interquartile range. Interquartile range is Q3 minus Q1. Okay. On the upside, you will take your quartile 3, whatever is the data point of the quartile 3, plus 1.5 times of the interquartile range. Any data point which lies beyond this Okay, so this is your upward up the upside data point. Any data point which is greater than this is an outlier towards the upside. On the downside, it would be Q1 minus 1.5 times the interquartile range. Any data point which is less than this, that is your outlier on the downward side. And it can happen in your finance data as well. So if you see stocks which are zooming too much, and it has not seen that range, then that's an outlier. It can happen in abnormal situation. It can happen in situations where it is not detected easily, but if you use a box plot, you can use it for anomaly detection. Another usage of box plot could be like, if suppose you have this kind of data, and this data is number of incidents that are happening on different days. So on weekday 1, okay, so the first on the day 1, you are seeing these many. So what you would have to do here is you need to get data where you can see the number of incidents which are happening for each different category of problems. Okay, so your category of problems are fixed. Okay, let's suppose you are a BPO, and you have a helpline, and in your helpline the category of problems are fixed. Okay, and for each category of problems, let's suppose on each day you note the calls that you are getting. Okay, so and you're open 24/7, so, and we are just taking it for 1 week, but this data can be aggregated for a month, and then you can do a box plot and then compare the results. So let's suppose this is day 1, and the category of problems you are seeing, so you, and let's say you have how many, we have taken 6, so suppose you had 6 category of problems, and these are the calls that you got throughout the day. Okay. Then for day 2, for those 6 problems, your calls changed, and so on. Okay, and suppose on the day 6, which is a Saturday, you get very less calls, or in fact you should get more calls, right? Saturday being a holiday, but I'm just taking an example here. On day 6 you get very less calls, and for few categories you do not get any calls, and you plot a box plot. This time I'm just letting it to be vertical equal to true. Now this is the kind of uh, box plot that you have got. So what is the conclusion you can make out of this box plot? So what does it shows? It shows the spread of data. So now here on my first day, I have data points for each category. So basically you'll have to also group them by category. Only by this would not help. You would also have to group them by category. So in the pandas, when you learn the group by clause, that you can use the group by a particular category, and then you can also plot the box plot there. Okay. The point I'm trying to make here is box plot can be helpful to see the spread of data. And if your spread of data is too large on a particular day, you can decide how many employees you want to call on that day. If your spread of data is too less on a particular day, you can decide how many employees you want to call on that day. Okay. And this could be over a wide range of days and wide range of problem set. So box plot you can also use for this kind of problems. So employee management, and then hence the food management, their vehicle management, that is one kind of thing. If you are monitoring electrical impulses, like the number of beeps that you're getting from, number of pings to your server that you're getting from certain location, based on that you can decide in which location you want to put on more servers. So this box plot is useful in so many ways. Colors, etc., we had already seen. Saving the figure we have seen. And box plot, it has certain more attributes like notch, etc., whether it is true or not, if vertical is false or something like that, the position, the widths you can give. Okay, and there are some of these, like if you want to show the means as well. The line that is shown currently is the median. Do you want to show the means also? Okay, the box properties, what is the color of the box, etc. Okay, what is the median properties? All these are dictionaries. Wherever you see a props, it is a dictionary. So basically these properties, what you can do is you can beautify your box plot, but I think you get the crux why, where and how you can use your box plots. Also it shows you the outliers. Very important stuff is the box plot showing the outliers. Similar to box plot, you have a violin plot. We'll take the same example and you can do the violin plot, and this is the kind of plot that you get. The function is violin plot. You pass the series. So this is your first series, second series, and the third series, and this is your data spread from 10 to 30, from 7 to 25, and this is your data spread. The difference between the box plot and this is shown like a violin. So wherever there is a maximum distribution of data, that portion is broader. Where the data is distributed thinly, that portion is thin. So here almost this side the data is almost like in the middle. Here there is a maybe large data, so between 20 and 25 the data points are more, so that's why this is curved like this. Okay, and like for example here in D2, in the series 2, you can see from 8 and 10, so this is very, this side is between 10 and 15, very few data points, and then here it's a broadening. So it shows you the density rather than this median, etc. And it shows you the start to the end. So if I have a data point, let's say 100, which is an outlier, so this doesn't show as an outlier, it shows the minimum and the maximum. Okay, the same data point, if I give here 100, this 100 would be shown as an outlier in the box plot. In the violin plot, the violin is adjusted from the minimum to the maximum. And violin, if you want to show your median, then you will have to select the attribute show median in the violin plot. Otherwise, it gives you the data density. I find box plot to be more useful, and violin plot is good if you want to show the data density and represent how data is skewed between what values to what values. But for the rest of the things, generally box plots is used. I hope this is helpful. I'll see you in the next section.